In this series we are building this massive 3D printed electric outboard that is 25 horsepower, 3D printed, carbon fiber, and a lot of different plastics by now. And in this episode I want to talk about mechanical failure, because I had one, and I want to show how I noticed it. That was actually by mistake, but also what I did to kind of fix it. And I also want to show how I put on this little thingy here. I built a mini mast to stabilize the motor. So I put this on finally, and if you've seen the previous videos, you saw me building this really strong, small, 3D printed, carbon fiber skinned mini mast to kind of stabilize the motor in this direction. So something really interesting happened tonight, and that was based on a mistake. And I'm also re-evaluating the use of ABS here. I was pulling this one pretty hard, I would say, but not super hard in any way, and it just snapped off. And as you can see, I printed this in this direction. You can see kind of the layer lines in this direction. So what happened is when I pulled, and ABS is ductile, strong, can have decently strong, but not as strong as PLA and polycarbonate and stuff like that. But it's also well known for having not that good layer adhesion. So if you put a lot of mechanical stress in one direction, which is in the printed direction, so what happened was that it just snapped off. You can see the other part here. I have it lying around here. You can kind of see that how they're printed there. So basically what happens is that it was sticking to the other part here, and then the stress became on those layer lines. So as this one is printed in this direction, this part was printed in this direction. So when I put force in one direction, it's ductile, so it does give a little bit, but actually that's more for small parts. For big parts they probably snap anyways. So I'm gonna have to reprint this lying down and in that direction so that if something is bending on it like this, it won't snap straight off like this one did. So sure, you could still have layer adhesion issues. We had an issue here where it snapped in the layer adhesion, probably because I put a lot of stress on it, and that's ABS again on layer adhesion. So I am going to reprint this in PLA Plus. And I had given up on PLA Plus because it's well known that, you know, if it gets hot it melts, but it's white, so it reflects all this, everything from the sun. So the white parts could have actually all been printed in PLA Plus, I think. The trickiness isn't in these places where the black part here could be quite warm. So here probably ABS is better. But I'd rather take the risk of having really the strongest, which is PLA, adding it to PLA Plus, which makes it a little bit more ductile. So, and having great layer adhesion compared to this. So I need to reprint it in that direction so it follows these lines. That's correct, that's not wrong. But I need to use a different plastic, PLA, which is like the standard, what everybody starts off with 3D printing. ABS is kind of, you need better machines usually, or enclosure at least. And yeah, but it was good. This is good. I do not want this to happen when I go out. I won't have anything to steer with. I would have to hold the motor by hand and try to go somewhere. So great that this happened now. I'll even think about if there's other ways I could make it mechanically stronger. Maybe adding, what's it called? These things there. It's late. Yeah. Interesting. So I just wanted to show how I'm printing it now. You can see it that I'm printing it in a lying direction, and these lines are definitely going to be strong because the pressure is not in the axis anymore of the layer lines. So you can kind of see how it builds up like 9 layer lines, and this builds most of the strength. It's not the infill, which we're getting to now. Like it's filling up all this area with, well, actually it's bottom layers, but you kind of get it. In the previous video I had taken the recording off, and this just had snapped off. So this is ABS and it warps, and I printed it in this direction. But so I have now printed a new one in PLA Plus, and it has longer, it has the screws in all the way, and I will now try to make a test to see if I can break this. If I can't break it by hand and it sticks, I'll trust it, but I'll use a lot of force. So basically pulling this one in there and then just pushing as hard as I can. So let's try. So let's put the foot in. Might be bending actually a little bit. Let's see if I can do even more. Something broke. What broke? It's the carbon tube. It's not cured. Well, better to find out now than later. Okay, so I was suspecting this could happen. The carbon is hard. Ooh, it developed heat. So you can see it, kind of the carbon giving here. So this is probably not good enough. I'm gonna go for steel, but I'm probably gonna put this around the steel just to make it look good. And the reason this is not working out is that I didn't do this the right way. So why didn't I do it the right way? Well, I had forgotten you need to cure it in an oven to get maximum strength. And I had not done that. Actually, I think just putting this one here would have helped. I mean, using the heater and just put a lot of heat through. But I didn't do that, and I don't have time. I want to get out on the water. So I will make it carbon to make it look good, but that's it. Let's go with that. So I printed this one out. I epoxied on the carbon fiber mini mast, and I used 2 bolts from each side as what's it called, inserts. So because I didn't have M4, and now we're putting this on and it fits. Yay. Well, I did try before, so I'm not surprised, but yeah, nice. I don't know, maybe a little bit Lee. Let's see. So we got those beautifully on, and they're tight. You can really feel it tightening against. I'm gonna leave that one because that was supposed to be a thing here to stop air come down to the propeller, but there are different types of connectors here, and it's important that you match the one. Like I have another one which is just bolt on and doesn't have these things, and it's important that you buy the ones with those. I didn't, so I have to order one from Amazon. It was like 40 bucks. But yeah, we have that one there, and I guess one of those, and then a nylock to make sure it doesn't want to run out from me. So yeah, cool. We'll just have to put that one on, and let's see. It's starting to look like a boat motor now. Cool. Oh, I'll have to do this with both hands. But anyways, we have gotten somewhere. So I'm losing a little bit of the propeller because, well, it goes down so much from the motor. So maybe I should have a bigger diameter one, but for now this will do. I think this is 8.5 inch. So yeah, looks cool. I'll have to build something here, maybe 3D print something that goes nicely out here to reduce resistance and weird things going on there. But overall, I think this is a success. Cool, huh?